last video, which was largely a conceptual introduction of what Raster was. Now we'll take it into ArcPro and actually start to play around a little bit with some of its mechanics. So this will be sort of a basic introductory technique video, and then there'll be one more this week that is a little more advanced. So first thing, if you want to follow along in the data from this week, I dragged in the elevation, land cover, and then parks and Euclidean example, really just as sort of context, the only reason that they're here, to juxtapose themselves against raster. Well, when you're in here, though, the first thing you're going to need to do, though, is come to project. And you're going to want to make sure that the ESRI extension that says spatial analyst is turned on. You want to make sure it says yes. If it doesn't, you'll go down to configure your licensing options and make sure you turn it to sort of licensed and get it on. I think it should naturally come up for you guys, but I just want to make sure that you do that and that it's showing up, because without spatial analyst, we won't be able to do any raster-based techniques. All right, so coming in here, I can see sort of two main rasters I have here, elevation and land cover. And, they both look different, and then they're also kind of colored pretty differently, which is an important element we'll come back to in a second. Elevation seems to be on a gradient, right, from a low to a high value, and is colored accordingly. And land cover seems to just have 5 values associated with it. So the first thing I'm going to do is I'm going to right-click and just sort of change the land cover colors a little bit. Maybe make urban gray. Give agricultural sort of a yellowish thing. Give the forests and shrubs a green. Wooder, that's already blue. And just make the other can be like a pink so it stands out. So the way that raster data is structured, it looks just sort of like a mess of colors from here. But as I start scrolling into it, I can see it actually is a series of individual cells, right? If they could all put their lines around them, you would see it appear like graph paper. And that's what raster is. It's like a piece of graph paper laid down on the world where each individual cell represents a value. In this instance, it represents a type of land cover, right? Whether you're urban, agricultural, forest, shrub, or wetlands. Now, it might be a little hard to see when I open elevation, but hopefully you can even here see, even though each grid cell is representing the actual elevation, and I can click one and just see that's 414 feet here, and this is 372. You can still see that same gridded pattern. So that's basically what raster is. And because raster is like a piece of graph paper and it's a grid, there are two sort of fundamental elements about raster that determine its size. And you can go to the properties to look at those just so we understand them. I believe they're under metadata or source. Let's see if it's under source. Perfect. Oops. Stop it. Great. Okay, raster information. So the two things that are the most important to look at here are the columns, rows, and then the cell size. So columns and rows, right, if you were to multiply those together, that would give you the total number of cells. That gives you basically the extent. So think about that like the size of the graph paper. The cell size tells you the actual size of the individual cells. So in this instance, it's 100. Anytime you see that, your first question should be, well, 100 what? Right, and you could zoom down to the spatial reference and see that this is projected in feet. Right, the linear unit here is feet, and therefore that would be 100 feet. So 100 feet by 100 feet. That's what we're looking at here. 100 feet by 100 feet, depicting us the land cover. The only other thing I want you to look at and just file away for a quick second is here where the pixel type is unsigned character. It's going to come in a minute why that's actually important. So we've got a thing of a certain size, and what we've got here looks sort of jagged, but that's really just because, we don't see the grid lines. But it's really like a piece of graph paper with each individual grid cell representing effectively a value. Well, let's actually start clicking on some of these, right? We clicked on elevation, but if I were to click on land cover, I see there's a field called land cover, but the value, the pixel value is 1. And this is really critical. I'm going to open the attribute table for land cover just so we can sort of see and begin to get a sense of how raster is structurally very different from vector. So when I open the raster and zoom out, I can see I only have 5 values, which is curious because there appear to be, tens, if not hundreds of thousands of pixels. And if I start clicking on each of the rows, I can see the way that raster is structured. All of the urban land, all 481,000 pixels that represent there's a piece of urban land here, processed together. They're stored roughly in the same row. All the forest and shrubs, all 594,523 raster grid cells of forest and shrub, they all process the same. They're all in the same column here. Now, this is fascinating because it leads to a very different way of structuring data. If this were vector, maybe if you dissolved, you'd get that. But, maybe the way vector would work is you'd have like this forest as a shapefile and this forest, and you'd have like a ton of records. But this really is treating all forests the same. Doesn't have to. There's way more advanced techniques in raster that the other class does where you could break this up and, define the values by the forest being contiguous or not. But know right now that it puts it all in roughly sort of the same row and processes together. The other critical thing to note is this value field. So ArcGIS is helping you by calling out like a name of the land cover because that's the way our minds work, right? Like land cover might be urban or wooder. What the hell does a land cover of 4 mean or a land cover of 1? That doesn't make any sense. But they have to be a number, is the larger point I'm trying to make here. Raster will only process numbers. So even in this instance where the value being represented is a character, right, like urban or agricultural, it still translates itself to a value. And this is important to know because there's really 3 kinds of rasters you can have. There's nominal, which is what we're looking at here, in name only, also called categorical. And the purpose of these is literally some kind of category is being represented with a number. This is that unsigned character I was mentioning earlier. 1 means urban, right? 2 means agricultural. It's important here because these numbers are effectively meaningless. You wouldn't take 2 farms, 2 agricultural lands, and add them and get wooder. That makes no sense. So in a minute when we start doing tools, you can't process these. You can't add them. You can only really query them almost like with raster's version of select by attribute. Show me the agriculture, show me the urban, show me the forest. A second piece that we don't have now but we'll create is called ordinal. Ordinal is similar in that, it's not like an actual integer-based number on a scale like temperature or home price, but it's numbers that are on sort of a scale of preference or order. The best way to think of ordinal is like when you go to the doctor and the doctor says, on a scale of 1 to 10, what's your pain level? It's like kind of a meaningless and arbitrary thing. You're not going to add 2 people that have pains of 2 together to get a pain of 4 necessarily. But we do know that if you had a pain of 9, you certainly have more than a pain of 3, right? And a pain of 2 is less than a pain of 4. So that's ordinal. It's when numbers are on a scale and you don't really add them or subtract them or do arithmetic, but they have meaning in their order. The final one, which we have an example of here in elevation, is linear, also known as continuous. And what linear or continuous means is that the values and their order have meaning and that they exist along a linear grid, such that in elevation, if I'm at 50 feet and you're at 100 feet, you're twice as high as me. If I have a crime density, of 10 crimes per square mile and yours is 30, then you have 3 times sort of the crime rate density that I would. These are probably the most common that we will use in this class. Today and next week we'll look at densities and elevations and interpolations, and all of those are on linear scales. They're sort of the easiest to comprehend because the values make sense here, right? 50 plus 50 equals 100. 1,000 feet minus 500 feet equals 500 feet. One thing just to note, and again, the other videos on my channel and the other class dives into this a little more, but it's pretty interesting how if you clicked on elevation, you can't see the attribute table. That's not a flaw, that's by design. Remember a moment ago that if I were to go to land cover and pick the attribute table, I can see everything. And I know that when I click on a given row, everything in that row selects, because the way data is structured with raster is all the same values processed together. So think about that from something like elevation, which quite literally treats 1,174.6 feet different from 1,174.59 feet. And each would have to have its own row. So do the math there, and you would need millions of rows of data. And they don't want to give you the ability to see that because that actually might crash your computer. I don't know if you've ever tried to open like a data set in Excel that has more than, heck, even more than like 100,000 rows. It starts to get slow. I mean, try opening something with millions of rows and it would crash. So the data's there, you just sort of can't see it. One other thing I want to show you that's, I think, more meaningful with elevation, if you come up to appearance here and pick the symbology of a raster, this is the most common one that you'll do for linear continuous values, right? A minimum to a maximum. And, it's just sort of like gradiated colors. The only real thing I think to notice here is the scale. Typically, people do either percent clip or standard deviation, where maybe the minimum and the maximum value that they stretch between are sort of within the bell curve, and then outliers aren't really processed. But you can also do minimum to maximum, right? I mean, it would change it slightly, but you could go from whatever the minimum value is to the maximum value. That means the minimum value would get a dark black, and the maximum value would get a dark white. You can choose different colors if you want. We can sort of make a comical appearing sort of topography here. We won't dive too much into that in this class, but just to know this is sort of how you would mess with your symbology and change it for elevation. The last sort of structural thing to know about raster, before I process one for you, is what's going on out here. I have consistently used this metaphor that raster is like a piece of graph paper, in that the extent is the paper itself, and then the cells, the cells are like the actual grids in the graph paper. And I mean, you can almost imagine, like if I took this, and I know you can't see through it, which is unfortunate, and imagine this is my like graph paper and I laid it over, it should be rectilinear. And so it's weird that when you look at this, like, okay, well, this isn't actually, rectilinear. So what's kind of going on here that I can't actually see like a rectangle, that it really looks like it is sort of, oops, no, I did not want that. It looks more sort of like a shape. And the reason has something to do with no data. I'm trying to remember where we see no data here. Can't remember if you can quickly visualize no data in ArcGIS. Just give me 1 second here. It doesn't look like you sort of can, but the concept of no data, just so you get a sense of what it is that out here there's values, right? Notice when I'm clicking around on these things, it says no data. And what that means is that even if you can't see it, in order to stretch out to a rectangle that has a sort of maximum point here, maximum point here, maximum point down there, and maximum point here, it didn't have values when I processed this, so it needed to create the values on its own. And so it treats them as no data. Literally, I have no information. It's almost like a black hole. If anything tried to add itself out here, like if I had values out here and I tried to add them to values here, it wouldn't work because I don't have any data here. So that's the last like little structural thing to notice. And so the first thing I'm gonna do is I'm just gonna like show you one or two easy processing techniques for raster, and then the next video we'll do some of the more sort of practical based techniques as well. So I want you to come over to analysis. I want you to go to tools, and I want you to go to toolbox, spatial analyst, map algebra, raster calculator. Again, in case I did that too quick, spatial analyst, map algebra, raster calculator. So this is the main sort of tool for processing raster. You know, if raster is still a little wonky for you, think in comparisons. Think about this as the select by attributes for raster. It's something that's going to use this janky looking calculator here, and anytime you see something like this, my best advice to you is don't type anything in yourself if you don't have to. This is clearly, you know, sort of encouraging you to click on a raster, to click on an operator. But the whole point here is that you write an expression here, and, you know, it returns to you values. And, you know, so maybe the easiest one is let's say land cover, and then let's find an equals one, double equals 1. And if you remember, the land cover value that was 1 is urban, right? So what I'm literally saying to it here is, you know, return to me all those areas where the land is urban. And I would run it, and it's going to come back with 2 values, 1 and 0. Now it's somewhat ordinal, right? 0 means the parameter was false, I'm not urban. 1 means the parameter was true, I am urban. And there we go, right? A different way of looking at the world, something that's not quite there. And now I can begin to use this to run other processes as well. Raster Calculator is cool because you can combine multiple things, right? This is when it really gets interesting. What if I were to say it's not just where, maybe we'll say 3, land covers 3 is forests, and then I'll find and, which is right here. Hate to tell you, this means or, guys, just get over it, right? It's crazy, it's weird, but that actually means or. And land cover equals 3, right? So I'm a forest. Land cover equals 3, and elevation is maybe greater than or equal to 700. So now I'm looking for elevated forests, right? Land where a forest is above 700 feet. And this is where raster becomes beautiful and seamless and brilliant and helps you truly map what's not quite there. I can see these by maybe jumping back and forth between them. But now I can actually find the land that exists in both. And I mean, this could go on forever, right? Land is forest, and the elevation is greater than 700, and it's less than 200 feet from a road, and so on, and so on, and so on. It is such a powerful tool for querying multiple pieces of data. And so, you know, I'll even maybe give this a name like, you know, high forests. And I could run it. Give it a second to do. It'll come back to me with 0 and 1, and there we go, right? 0, both of the criteria are false. 1, I'm an elevated forest. So it's a really cool tool. And, you know, it's also one that we're not really going to dive into this class, but it doesn't just have to be these sort of queries. You can also add things together, and if you had multiple rasters, you could add them or subtract them or multiply them. Very useful, sort of very cool tool that helps you in the querying of rasters. So I'm going to end this video real quick with, you know, how you also create your own raster. You know, we're going to work on this in the next video too from data points, but one of the ways you can create is through direct conversions. And so if I open these up and I see that they're parks, you know, I might look through them and see if there's a field. Great, there's a field here that says park is 1. And so I can come right up to tools, and I can go to conversion, and then I'll say to raster, and I'll say feature to raster, input the park. This is a critical thing, you know, remember, because raster really is looking for one value that defines it, right? The value in land cover was a number representing the type of land. The value in elevation is the actual elevation in feet, right? The value in high forests is a 0, 1, true, false that says, are you a forest above 700 feet or not? So you just need to find a value that defines what you're looking for, right? In this instance, it's park. You got a value of 1 if you were a park. You also usually need to pick a cell size and an extent. The way I recommend doing this is if you have other rasters that already exist, like we do elevation and land cover, I want you to come over to your environments, and I want you to just say, hey, match the extent to land cover, and match the cell size to land cover. And that'll just ensure that when you run a tool like this, it'll sort of automatically do, make sure that the pieces of graph paper are the same size so they lay on top of each other perfectly. And so I'll run it, and effectively it's just sort of going to take the same shapes here. It's going to digitize them, give them a value of 1, and everything else will be 0. And give it 1 second. And there we go. And now we have sort of digitized the parks and can scroll in and see, if I click on one, that's obviously a value of 1, meaning that you're a park, and everything else would be a value of no data. So that's the basics of rasters. So I'll open up the next video. We'll look at a couple of, more specialized ones, and take it from there.